Yeah, hi everyone. We'll be waiting 2 more minutes. We'll be waiting 2 more minutes for others to join, and then we can start the webinar. Yeah, hi everyone. We'll be waiting 2 more minutes. We'll be waiting 2 more minutes for others to join. I think we can start now. Okay, so hello everyone and greetings from Shiksha Online. This is your host Abhilasha Sharma. And today, the topic of our webinar will be Android app development. And the speaker of today's webinar is Saurabh Gupta. He's a senior software engineer at InfoEdge, and he will be talking about all the essential skills that are needed to develop an Android app and how can you move forward with it. So for rest of it, I am now handing over the session. Until then, whatever doubts and queries you will be having along with the explanation during the session, you can drop all of it in the chat box so that I can tell it to the speaker on the spot and then he can clear your doubts and questions accordingly. Okay, so all right, let's start with the session. Saurabh, you can start it.
Okay, so hi everyone. This session will be a brief introduction to Android development and a step-by-step guide for the same. So, first of all, let's understand what is Android. So, Android is a Linux-based operating system, which you already know is used on smartphones, Wear OS, watches, smartphones, TV, and tablets. So you can say Android is everywhere. And about the market share, I would say that it covers almost 71% of the mobile market, while iOS covers 27%. So, so let me just tell you why we are using Android. So it gives the stunning user interfaces and leveraging powerful APIs and a comprehensive essential knowledge and skills to become a accomplished Android developer. So the main advantage of Android is the Android ecosystem because it is very vast. So let's understand about the Android ecosystem, how it works. First of all, we need Android Studio to develop an Android app. So, so Android Studio is basically an IDE, which is an integrated development environment for Android development. So, it also provides debugging and testing your applications. So, it provides tools for that. And second, we move to Android SDK. So, it is a collection of software tools and APIs that enable developer to create Android applications. It also include libraries, debugging tools like we use debugger. Suppose our code is not running, so we have to check at which point our code is breaking. So for that we use debugger debugging tools, and we also have an emulator to simulate the real smartphone. And then we have an Android platform itself, which is basically an Android operating system, which is the foundation upon which your application runs. So so it's just an operating system and a user interface and a system level services that your Android app use. And then we move towards Android ecosystem. So as I've already said, Android ecosystem is a vast network of developers itself. So the community is very large here. So that's the main advantage of Android. Now let's move towards setting up Android Studio and SDK. How we do. So first of all, you can visit the Android Studio Android website, and then you can easily install the Android Studio, uh, uh, respective of your the operating system that you are using. And then you can simply launch the Android Studio, and then you have to install the SDKs, which I've already mentioned, the Android SDKs that you need to use. Then you have to configure the IDE settings, that is the JDK path, that is the Java path you have to set up. And then after that, you can just simply create a new project and then set up Android Studio. and then you have to download the components. So the components that you can customize, and then you have to set up the AVD. AVD is the emulator which I have talked about earlier. So it is an emulator which you can install and on which you can run your app. And then we have the Gradle files. So Gradle files basically contain the dependencies that you have to use inside your application. So these are the third party libraries that we use, and then you can just hit the run button and then you can uh, run your Android application. So like I would like to show you the Android studio, how it looks like. So here's the Android studio. So you can simply create a new project from here and then you can continue with it. So I've already created a project. So what it contains a manifest file. So it is the core of the application where you have to set up like intent filters and the activities that you have created. And so activity basically you can say it is a UI page, you can say, on which your UI renders. And then you have the Gradle files, which is the project level Gradles, and also the app level Gradles, that is a module level Gradles. So here you can say there are many libraries here. That is Android core library, Android lifecycle, and also for the test also. So we can write the unit test here. So these all things it has, and the main logic that we write is the activity. So this is the main activity. So main activity. Let me show you. Let me just run this app and show how it looks. So this is the emulator that I was talking about. So I've already created an application. We just print the greetings here. That is, I pass the list and just prints the greetings. So how it works. So as I already told, activity is the main entry point of the application where your application starts. And the code which you are seeing here is in Jetpack Compose. So let me just go back to the slide and just tell you how we can create the UIs. And the programming language that we use for native Android development is Kotlin, which is official language for native Android, which is recommended by Google. So the all the code that we write, the logic part as well as the UI part, we can write in Kotlin. And why we are using Kotlin and not Java? Because Kotlin has a very concise syntax. That is, we can build a feature in less amount of code, and it has safety. Null safety is a feature that is provided by Kotlin to avoid null pointer exceptions, and it also has interoperability with Java. So you can use Kotlin as well as Java side by side in your project. And it has also a feature of extension functions and coroutines for asynchronous programming. So coroutines is a very powerful feature of Kotlin that we use for API handling. And we also have smart class data classes. So data classes are also very important. Let's say you want to store a user data. So for that, to hold that data, so we use the data classes. And the data classes also and the data classes also provides the constructor. So in the constructor, we pass the user's data and it automatically saves. It also provides a very helpful functions like hash code and all. So this is it, and you can also see the example of a button click here. So we can just use a set on click listener on a button, and then we can use it. So let me talk you about the Android components. So the activity, first of all, the Android components includes these 5 components. So these are the main one through which we build an application. So an activity represents a single screen with a user interface. It is a crucial part of the application through which the Android application starts. So let me just, so you can see this is the main activity, and which is the base activity through which the application starts. It is a launcher activity. So from here, application will start. Now coming back to the uh, Android components, the second one is the fragments. So fragments are basically a sub part of an activity, you can say. Let's say you have an activity, and then inside that activity you have many fragments. So fragments are a sub UI of the main UI. So activity includes the whole screen size UI, and the fragment you can create a multiple fragments in the activities, which you can handle simultaneously. So it allows for modular design. Let's say you want to reuse a UI somewhere in your application, then you can use it with fragments. Then comes the services. So services are basically the component that runs in the background. Let's say you want to hit an API in the background. So for that we can use services. Even though app is not running, but still you can use the services to do your work. And then there is broadcast receivers. So broadcast receivers, you can say that these are the receivers that intercept the system level events. So system level events, you can say, let's say when we are charging our mobile, so whenever we plug the charger, then Android system broadcast an event that there is a USB attached to the phone, so that we can intercept using broadcast receivers. And also there are content providers that is used to manage access to the structured set of data. So let's say you want to share some data between the apps, then you can use the content providers. Then there are, as I have already told you about that, we can build UI with two ways, that are through XMLs and Kotlin. So I've already told you about the Kotlin ways. As you can see here, this all code is written in Kotlin, and no XML is used here. And because Jetpack Compose is now the recommended way of building a UI, because because the languages are same in UI as well as the logic part, so it is much more efficient. And also the Jetpack Compose is also very reusable. It has the modular code. We can build many features with less amount of code. But still we can review the XMLs. Like there are XML layouts. So layouts, basically you can say the hierarchy part. Let's say you want to arrange some UI elements in a row, then you can use linear layouts with the orientation as horizontal or vertical. And let's say you want to arrange some element, let's say relative to some other element, then you can use relative layout or the uh, fragment layout. And then we have the view and view groups. So view, you can say a smallest unit of UI we can say as view. Let's say a button or a text on a screen, that is a view. And the view group is the parent of the views. Let's say we wrap some views inside the view group. So view group includes the layouts, as I've told you earlier. And there are the layout managers, which provide a, let's say, a linear layout, relative layout, constant layout, which allow you to control the positioning and behavior of the UI elements. Now let me just show you how we use the Jetpack Compose. Okay, you can say here, see here, there is a code labs provided by Google, which you can just start. And you can see here that it is a simple app that is created, that is a happy birthday app, you can say. You have to just pass the name and it prints the happy birthday. So this is a very simple app, and these code labs are very helpful if you want to learn Android development. These are the tutorials provided by Google itself, so you can just see that. So here they have used the Jetpack Compose, why use the functions and the annotations part. So I will just explain you that in the code itself. So first of all, the UI element has a composable annotation. So composable, you can say it is the smallest unit of UI that we want to display. So and we have to and it is based on functional programming. That's why we use the function, and then we have the function name greeting, and we have to pass some parameters. So here I passed the name of the person, and also the modifier. Modifier, you can say it is a styling of the child components. So let's say I've used a column. So inside the column, I've used a text. So these are all the predefined composables. Let me just go inside that. So here you can say it is a column type of composable, and here it is text type of composable, and it has these many parameters we can modify, like font style, font weight, font family, and the color of the text. These all things we can modify. And then comes the uh, and then how to render it. First of all, we have a set content method inside the main activity. So inside the main activity, we can define the theme of our app. Like here it is demo application theme, and then inside that theme, we can use a parent layout. Let's say there is a box. Inside the box, you can just pass the composable. So here I printed the multiple greeting composable. So let's say I will just let's say I just increase the, let's say, 90 and 56, 78, 43. So right now it is like till 34, and if I have run, so I will just show you how it is working. So you can say it is still 34, like 90, 56, all are printed. So how it works, first of all, it calls this method, that is the multiple greetings part, and then it comes here, and then we have provided a list, and using this list, I've used a lazy column. So column, you can say if you want to arrange elements vertically, then we use the column. And lazy column is used when we have paginated data, or we have a large amount of data. Then we can use the lazy column. Inside the column, we have items function, and we have to just pass the list, and this list returns a single element, and then I have passed into another composable. So this item is passed to another composable, that is the greeting part. So this is another UI element, and this UI element, what it does is simply prints the text. So text alignment center, and then it prints the hello, and then the name which I provided from here, it just goes to the text, and then there is a font size and modifier. Now let's say I just create a different composable here. If I want to just print it in a row, let's say demo composable. Let's say I created a row. Okay, let me just tell you about the rows and all together. Let me just print a single text. So this is text 1. Then we have so I have to call this function from the set content method in order to display it. So I will just call this function, and I'll just run the application. So you can see that text 1 and text 2 are overlapping here, right? So if you want to just let's say arrange in a row or a column, we have to apply a row or column modifier, row or column composable. So that is the row. If you just pass the row, they will be arranged side by side. And if I just change it to column, it will be in a vertical order. So also you can assign that the text alignment, center, and also the font size and the modifier. So modifier is just like the CSS in web. It is used to style the components. So let's say I'm just putting the font size to, let's say, 16.sp. Here font size to 18.sp. Here you can see it is slightly bigger in size. Let's say just create it at 28 sp. So you can say it is a live edit feature by Compose. So this is how it works. So just like column and row and like text, there are many composables present in already provided by the library itself. So you can say it has used the greeting and then composable, and then it has print the birthday card with a greeting text. So it has to just pass the message. It will just create it. So they have also provided the rows and columns. So you can just type like the layouts in Compose, and you can just check. So they are basically three layouts. That is the row, column, and the box. Box, you can say it is just like the stack. So it stacks element one over another. So here you can see it has created the two text, and these are overlapping. So how to just adjust it? So it is the so we have used the column row to adjust it vertically, and in order to do it in the row column, we can use the row modifier. And then we have the images image modifier, and we can pass in the svg web images, or maybe the image url to render the image. So here are the three modifiers that we use. There is a box, that is the stack part, then there is a row, and there is a column. So this was all about the layout. And then let's talk about the activity lifecycle. So how it works. So basically, activity is, as I've already told you, it is just the UI rendering on the screen. In simple words, if I say. So first of all, there are various lifecycle callbacks that we receive, and these callbacks are received by the app itself. And and why we use these callbacks? In order to, let's say, we are using some resources from Android OS, and and if you want, let's say our app is uh, is in the background, then we have to release those resources so that other apps can use it. So for that, we use the Android lifecycle callbacks. And let's say your app opens, and if you want to get some data from the backend, then you can call some APIs in the onCreate function. So onCreate function is called whenever the app is opened. So the activity lifecycle function will be called. So it gives us the callback whenever the activity is first created. So here you should set up the initial UI part, and bind the data with the UI. And then we have the onStart function. So onStart function is called whenever our app UI is just about to get visible to the user. Then the onStart is called. And onResume is called when user is actively interacting with the application. And then opposite to these events, we have the on pause event. Let's say you press the back button of an application, then on pause is called, which is corresponding to on resume. And then and then there is on stop will be called, which is corresponding to on start. And then on destroy will be called, which is corresponding to on create. So these are all the lifecycle callbacks methods that we can use, and these are very essential if you want to master Android development. And then there comes the Android manifest file. So, which I've already discussed in the project. So, this is the Android manifest file. So, it has the application name, and also we have to define all the services, activities, broadcast receivers in the Android manifest itself, because Android OS directly interacts with the Android manifest. So, that's why it is very important. So here we have package name and the application components like activity, services, receivers, and provider content providers. And then we have the permissions that we have to ask from the users. Let's say we want to use the location permission, then we use this users permission tag in the Android manifest itself. And then there are the hardware software features. Suppose if you want to use in the app, then we can use the users feature and the users SDK tags in the Android manifest file. And also, let's say if we have application metadata, then we use the application tag, which is already included here. And then after that, layouts, I've already told you, these are the linear layouts. And so these were used in the XMLs. But if you want to go for Jetpack Compose, we use mainly the constraint layouts. And also, as I already told you about the box and column composables. Then we go towards the storing and managing data. So app also has a feature of storing data in app itself, and how it does it is through SQLite databases and shared preferences and room persistence library. So SQLite databases you can consider is it as a tables uh, through which you can run the queries and get the data, same as the backend. So it is a very powerful tool for Android. Let's say if you want to create an offline application, then you have to store some data. So that data you can store in the room persistent library. So it is a modern and abstracted way for SQLite databases. So it is provided by Google, that is a room library, which is an abstraction over SQLite database. So it has also the features like insert delete, which it automatically handles. And if you want to create a query which is custom query, we can use a query annotation inside the room. And then we have the shared preference are used when we want to store a small amount of data. Let's say you want to store just the username inside the application, and and let's say small amount of user data, then we use a shared preference. If you want to store a large amount of data, then we use room persistence library. Then we have the testing and quality assurance in Android, how we do it. So we can write the unit test. Let's say you have written a code, then if you want to write test for it, so you can just create a text directory, and you can just write the unit test using JUnit, and it is mainly written by the developer itself, so that so that let's say there is a team working on an application, and and let's say if we are releasing a new feature, so so we want to ensure that the new feature does not break our old feature. So for old for the old features, we have unit test. So whenever we run the unit test, it just checks automatically what all things are breaking inside the unit test. And then there is a UI testing, which we can use, which we can write the UI test. And then there is integration testing. We have to just integrate our modules and all, so that we have to check whether the all the integration parts is working as expected or not. And then there is CI/CD we can set up with our application. CI/CD is basically a continuous integration pipeline through which we can automate the build, testing, and deployment of our application. And then how do you publish your app to Google Play Store? First, you need to have a developer account on your Google Play Store, and there is also one-time registration fee for that. Then you have to just create a new application on the Google Play console and fill in the basic information about the app. And then you have to prepare the store listings as well, like the app description, screenshots, and a screenshot of the applications, icons, features, and then categorization to which category your app belongs, and then upload the signed APK, that is the app releases, and then the content rating part, like the questionnaire that we have to receive a rating for your application, and then we have a set pricing and distribution, define the pricing free or paid, that is our app is actually a free or a paid version. Then there is a review and publish. Whenever we release our app, it is reviewed by Google, and then it only get published. So if it meets the Google Play policies, then only it will be published. Otherwise, it will get rejected. So it usually takes around like half a day, and sometimes it may go up to 3 days as well. And then like how to just go about Android development, like uh, how to get updated with Android, like what are the feature, like uh, like the new features that we get in Android, how to get updated with that. So for that, you should be updated with the documentation part, and also the IO sessions which are provided by Google. And then there are various platform which provides uh, the video tutorials which you can follow on YouTube as well. And then there is a broader Android developer community which you can use, also the Reddit or the Stack Overflows you can use, or the local meetups which are done by some companies which you can join. And also you should be curious and continuously expanding your knowledge, and reading regularly industry blogs and all. So the main thing is you should read the documentation, and you should be updated with that. And also you can join the community on Twitter as well, where you can just connect with the developers. And then there is some advanced topics to learn. So, like as I already told you, there is a Kotlin extension scope functions which you should learn, and also there is MVVM, that is the design pattern which you should follow if you are writing a production ready code. And there is recycler view, then there is a retrofit, which I will explain one by one. First of all, let's just see the Kotlin documentation, how it looks, where you should learn from. So you can just go for the Kotlin docs, and here you should go for the basic syntax, and from here you can just start, like what is the entry point of an Kotlin application. That is the main method, and for the function we have a keyword called fun. So we should add the fun keyword, and then there is a function name, and then there is a parenthesis and curly brace inside. This is the function body which it prints, and then you can just see these are the parameterized function. Here you can just pass in the input, and you get integer as an output, right? So here I can just uh, I will just show I have created a function. So here this is a function, and I have created a demo composable. So I have not passed anything, but it is giving me a UI. So it just emits the UI. That's why composable annotation is used here. So it gives the compiler a indication that this is going to generate a UI. So accordingly, it will create a UI hierarchy. And then you can just say that there is how to declare a variables, and also you have two types of variables, val and var, which you should learn from here. Let's say if you do not want to change a value, then you should use val. Otherwise, you should use var. And then we have classes. You should learn about object oriented programming if you are learning for the first time. then you should go for the object oriented programming. Otherwise, if you already know, then you can easily understand from here that it is a class, and then there is a constructor. In the constructor, we have some parameters. Let's say this is a class called rectangle. Here we have height and length of a rectangle, and it just calculates a parameter, right? So this you can use, and also you can just here it is. We can use the inheritance concept here. So inheritance, let's say if we have a parent class, and if we want to give those property of the parent class to the child class as well, then we can just use colon operator here, and then pass in the parent class, and then it automatically handles the parent class properties. And then this is one of the interesting feature in the Kotlin. This is the string templates. So here you can just write, let's say A is, and then the dollar sign, then A. So after dollar sign, this is a placeholder, which is coming from here. So I have also used a placeholder here, which I would like to show. Here it is a placeholder. I'm passing the name from here, and it goes here. So this is string interpolation. So it automatically just plays the name which I have passed, and it generates the string at the runtime. So this is a string template, and then there's a conditional statements which you have to use, and for loops and all these all basic things you need to learn before starting Android development. So you should be thorough with Kotlin first, and then there is a composable doc. Let's say you have finished with Kotlin and you want to start with Android, then I would highly recommend that you should start with this tutorial, which is provided by Google itself. So which is a compose tutorial. So they have created a chat application here. So it includes only the front end part, that how it creates a chat application with a less amount of code, right? So they have created a full chat application. So I would like to just share that if you want to make a UI, then you should break it into component first. So let's say there is an image here. So it is a component. So make a separate UI for this image, and then there is this text part. So you should create a separate UI for this, and the separate UI for this, and then combine all these into a single composable part. So overall you have created a three composables and then combine into a single composable. So it will create a UI hierarchy automatically. So they have created a full chat application. You can refer to this doc. And then let me just share some insights about the advanced topics which you can refer later. There's a Kotlin extension functions you can use, and there's a scope functions like if you're dealing with objects and classes, then on an object you can apply scope functions. So it reduces the amount of code. First of all, so scope functions are apply and with. So these are all the scope functions. So you can read it later. And then there's a model view model architecture. So it is a design pattern recommended by Google. So it is used for writing scalable codes. Let's say, and let's say we are releasing a feature, and suppose later in time we have to add another feature to it. So so if the code is not scalable, then you have to write it from scratch. So it should be scalable, so that we can add various features without uh, without changing the earlier code. And then so I will just show you about the model view model and medium architecture. So you can refer to this website called Android Developers. So it has all the docs provided. So you can use you can see that why we use this feature. MVVM. MVVM is model view model. So model is basically the database part, you can say, and view is the UI part, and the view model is a intermediate between model and view. So you can say that let's say we have an offline application, and we are using a room library. Room library is for creating the database in app itself. So let's say we are creating an application, and then how do we write that code? So for writing a proper pattern for that, we should separate the UI layer, and the view model contains all the business logic, all the logic handling that we should use. So let's say we are getting a data from the database, and we want to modify it, and then after modifying, then we have to show it to the UI. So for that modifying logic, it should be written in the view model, which is the middle layer between the view and the model. And then we can say then we have also the concept of repositories. So repositories, you can say, it is a common point, it is a source of truth from which we get the data. Let's say you have an application, um, um, and in that application you want to fetch data, like some data from the backend, and some from the app itself, like from the room database, and you have to combine those data, and then give it to the view model part, and then show it to the UI. So for that, we use the repositories because it combines the data from the backend as well as the room database. So it has the data sources, and there are some benefits which I've already told. It improves the maintainability, quality, and robustness of the overall application, and it brings the consistency to your project. So it is more efficient because we are able to code in less amount of time. And then there is a recycler view, which I have already used. So recycler view, it is just for storing, showing uh, the similar UI elements inside a column or a row. So here in Compose, we do not have a recycler view concept, but we have a lazy column. So it works similar to the recycler view. So what it does, what is the benefit of recycler view? Let's say there is a list of contacts, and let's say you have around, let's say, 2000 contacts, and the user has opened the app, and he's only seeing, let's say, 10 contacts on the screen. So if you do not use recycler view, then in that case it will generate 200 UIs of all the contacts. So in order to efficiently use the memory, we use a lazy column or the lazy row. So lazy column is basically a recycler view. As the name suggests, it is a recycler. So it just recycle the view. So let's say a user is only watching the 10 contacts on the screen. So it just create a slightly let's say one or two views extra. Let's say it creates only the 12 views. So whenever the user scrolls the application, so it is only using those 12 views itself. So what it does, whenever you user scroll, it just replace the data in that view. So it is not creating 200 views, it is just creating 12 views. So that's why we use the lazy column or lazy row for the optimization part. So it is very important component. And then we go for retrofit. It is an advanced topic. If you want to interact with backend APIs, then we use the retrofit, like get and post method, if you want to get some data from the backend. So and then coil is a library which is used for image loading at runtime. Let's say you provide a URL, and then you have to show that URL. So coil fetches that images and then display it on the UI. So this is the coil for image loading, and then there is a navigation in Android. So here we were only talking about a single page application. Here I've already created a single page. Let's say if we want to create multiple pages. So there is a library provided by Google which is navigation. So we can use a navigation library through which we can seamlessly just interact with various pages in our app, right? So this is the navigation library. Let's say you are in let's say you have a bottom navigation inside your app, and you have four sections. Let's say a dashboard, profile, and and let's say responses. So in that case, if you want to navigate from profile to the dashboard section, then you just tap on the bottom navigation and it just replaces that fragment. And that is possible through the navigation. We can also do it manually using fragment transactions, but Google has already created a library which is a wrapper over that fragment transaction. So you can search for the fragment transactions in Android. And then we have work manager. So work manager is basically for doing the background work in our application. Let's say you want to fetch some data from the backend, some important data which gets updated like let's say every 24 hours. Or let's say if you want to send some data from app to the backend uh, in some periodic time, or let's say one time. So we use a work manager here. So even if our app is not open, then we can use its work manager to do our work. And then there's a broadcast receiver, which I've already told is it is used for receiving the system level Android system level events. And then there is a paging library. So paging library is basically for implementing the pagination on app itself. Let's say you have a jobs application. So in the jobs application, if you want to, let's say let's say the database has around, let's say, 2 lakh jobs. So we are not going to bring those 2 lakh jobs to our phone, right? Because it is not even feasible, and also it will take a large amount of time for the API to just give the result. So for that, to just minimize the network bandwidth and the storage, so we use the paging 3 library. So what paging 3 does is we have to just send the page size to the backend, and it just only gives those amount of jobs. Let's say our page size is 10. So you have to just pass the page number and the page size. So let's say I have opened the application and I have paging implemented in that application. So whenever I open that application, I just first I will pass page is equal to 1, and then I will pass page size. Let's say we have 10, which is fixed. So whenever the user scrolls through all the 10 jobs, it will again automatically hit the API for page number 2. So it gives us the seamless experience. So it gives us the um, effect that it has a infinite number of jobs here, right? So that's why paging 3 is used. And then room database, as I've already told you, it is used for creating a table in app itself. It is very powerful tool if you want to store some data, a large amount of data. So you can uh, uh, so you can query some data inside the tables. So uh, through that we can just send it to the repository part, that is the data source part, and through that we can go for the view model and then to the UI part, right? So we can use these. And then there is a, I will have to show you about the where we keep the resources, right? So we have a drawable part in which we create, in which we put our icons. Let's say, see, you can see here, here is a default icon provided by Android for our application. So if I just minimize that, you can see the application. So here it is. So it is using the same icon here. That is a demo application. So we click on that, it just creates that. And then we have the values folder. Here we have colors, they are predefined colors, but we can also add more colors here. And why this file is used? Because let's say if you want to use the same color everywhere in the code, so instead of writing the hex code everywhere, you can just give a name to that color and then use that everywhere. So So if you want to, let's say in future, if you want to change that particular color to some other color, let's say you want to replace that color in overall all the app. So what you have to do is just uh, update that color in the colors file, and then it get automatically reflected everywhere. So that's why we use the resources file. And then similarly, we have the the string file, which is a application name, is a demo application. We can write the string here. Let's say let's say username or some placeholders we can add here. Then we have a theme which we are using here. That is a light theme with a no action bar, which we can modify our themes here. Let's say if you want to customize the component, let's say a view or a text view, if you want to customize, then you can provide the theme for that view inside this themes file. And then you can see here about this is the test file which is automatically generated. So this is how we write our test. So this is an instrumentation test, and inside we have unit test. So for
Yeah, I think there might be a network problem. We can just wait for a minute for our speaker to continue. Yeah,
hello.
I think there might be a network problem. Saurabh, am I audible to you?
Okay, yeah, hello.
Yeah, yeah. Am I audible to you?
Yes, yes, you are audible.
Yeah, yeah. You can continue. We have to wrap it up.
Okay,
Yeah, then we have to move forward to the Q&A round also.
okay.
Yeah.
Yeah, so I was just telling about the unit test. So basically, uh, the difference between unit test and instrumentation test is that here we just simply checks the logic which is not dependent on the UI. So here it just checks whether 2 plus 2 is 4. So it just gives the result as true. So it will just pass the test case. So assert function is used. So we have to put one a value here, and then we have to put the actual the logic part here. So if we, and then we have to compare whether that logic gives the result that we are expecting. So that's how the unit test works. And and about the instrumentation test, it is a combination of UI test. um, so it just checks the UI, and it is done with an emulator. So it is generally slower because we need emulator in instrumentation, while in unit test we do not need emulator. We can just run it without an emulator.
All right. I think we
Yeah,
might now move forward to the Q&A round.
right.
Yeah, so I have a few questions already lined up.
Hmm.
So the first question is that an attendee asked that what tools or libraries do you use for testing and debugging Android apps?
So basically, for testing, you can use RoboElectric or the Espresso library and the JUnit, as it is already mentioned here. We can use this library and also the Android unit test library. So we can use these libraries, and also to create mocks, you can use Mockito or the mock library for the testing part. And for the debugging, it is we have an Android debugger here, so you can see. So we have an Android debugger. We can use this. So it is a built-in feature in Android Studio for debugging.
All right. Another question that has been asked is can you explain your process for handling app updates and maintenance post-launch?
About the app updates.
Yeah,
Okay.
after the launching, post-launch, it is written.
After the post-launch, we generally have we generally monitor it through Firebase. First of all, we have Firebase integrated in our app, so it gives us the Crashlytics part. So first we release it on a very few users, let's say 2 to 3% users, and then we check the Firebase if our app is working fine or not, and then we slowly increase the rollout percentage. And then for the app updates, it automatically increase the rollout to simply 100% whenever we feel that okay, that our app is working fine. And before releasing our app, we have to increase the version number. So it is mandatory to increase the version number. And if you're using the database library, then also if you have made some changes in schema in app, then you also have to update that schema, that database version as well.
All right. Are there any other questions? I have only received two of them. Are there any other questions anyone would want to ask or want to get it clear? Till then, I am also launching a feedback poll. It might be appearing on your screens. Yeah. So you can fill it out. Just take a minute to fill it out. Until then, you can also think about any doubts or queries you have. This is a feedback poll regarding the webinar and how was your experience and how would you like to, recommend it to other people and what would you want like a topic for your next webinar. So just take a minute to fill out this poll and till then you can also ask any doubts or queries if you have. I would request all the participants, all the attendees to just fill this out so I can then end it. Okay, there is one question, Saurabh. So, a participant asked that a perfect roadmap for app development engineer. What can be a perfect roadmap for an app development engineer?
So for the app development, you first have to master the programming language that we use, that is Kotlin. So let's say if you are a beginner, then you have to first clear all the concepts like object-oriented programming concepts. So it might be 15 to 20 days. And if you're a beginner, but if you are already experienced and you have an experience in another language, then you can easily migrate to Kotlin. And uh, so it so it is relatively simple. So it might take around like 4 to 5 days to just uh, get clear with the Kotlin part, and then you have to start the Android development. Then for Android development, you should create some basic apps like to do apps and all, which you can find tutorials on the YouTube, or you can also refer to the Google Code Labs, which I've already shown in the slides. So for the Google Code Labs, as I've already told, that these are the code labs provided by Google itself. So they are reliable and they are easily understandable. So you can just follow all these code labs, and then you can uh, be at intermediate level. And after that, I've also included some advanced topics in the slides, which were these like MVVM. Let's say if you want to, let's say if you want to write a production ready code, which the user is using, then you have to master these concepts like model view model architectures, and then there is a recycler views, retrofit. These all libraries then you have to master. So I would just summarize that you should try to build a basic app, and then for example, calculator or a to-do app, and then use some components like in-app caching, that is a room database or shared preference, and then you should move on to the API interaction part, and then you should move towards the app optimization part.
All right, I think there are not any more questions from our
Hmm.
side. Uh, I think it's all clear. All right, so we'll wrap it up now. Thank you so much, Saurabh, for your time. And I think the webinar was wonderful. And
Okay.
I hope all the doubts and the queries were cleared. Thank you so
Yeah.
much.
Okay. Thank you. Thank you, guys.